Hello, welcome to the last lecture on interpretation of statistical information. Our learning outcomes are to plot a scatter diagram and to interpret qualitatively from a scatter diagram if correlation between variables is positive, negative, or none. So what is a scatter diagram? Well, these are all scatter diagrams, 3 examples. Each diagram shows the relationship between 2 different variables. The first is comparing height with intelligence. The second is comparing the age of a car with the price of a car. And the third is comparing dimensions, the length of something compared to the breadth of something. Breadth is another word for width. So we also have correlation. We can see from the scatter diagrams if the 2 variables are related to each other. In other words, if one variable is affected by the other, or if they are independent of each other. And this is called correlation. We will consider 3 types of correlation: positive linear correlation, negative linear correlation, and no linear correlation. So let's look at each of those to see what it is. And the first one, positive linear correlation. And this is where one variable increases, then so does the other. We can see, if we consider from this point to this point, then as you can see on the diagram, then as the horizontal variable increases, then the vertical variable also increases. And we can see from the diagram that there is a straight line pattern. Now, straight lines we know are linear relationships, and hence the term linear, positive linear correlation. So if the scatter diagram has this pattern, then it is said to have positive linear correlation. Next, we have negative linear correlation, and this is where one variable increases, the other variable decreases. So let's compare 2 points again. If we consider, say, that point and that point, we can see that the horizontal variable has increased, but the vertical variable has decreased, and this is negative correlation. And as before, we can see there is a straight line pattern. So again, this is a linear relationship. And if a scatter diagram has this pattern, then it is said to have negative linear correlation. The third example is where the variables are independent of each other. There is no pattern. And you can see that if I consider that point and that point, then the horizontal variable has increased and the vertical variable has increased. But if I then consider this point from the same original point, then again horizontal variable has increased, but this time vertical variable has decreased. So sometimes the variables increase together, but sometimes as one increases, the other decreases. So there is no straight line pattern and therefore no linear correlation. Now you may have guessed that there are other types of correlation, non-linear correlation. However, in this course we will only consider linear correlation, straight line correlation. So from here we will just refer to positive correlation, negative correlation, or no correlation. But we are talking about linear correlation. Let's look at an example. In the study of a city, the population density, that's the number of people per hectare, and a hectare is a unit of measurement. 1 hectare is 10,000 metres squared. So the number of people per 10,000 metres squared. Let's look at that, population density, and the distance from the city centre in kilometres. And this was investigated by picking sample areas. So for each area, say area A, the distance to the city centre was measured, 0.6 kilometres, and the population density was also measured for that area. And in this case, we found that there were 50 people per hectare in this area. And we have several different areas to consider. And the question asks us to plot a scatter diagram, describe the type of correlation, and interpret the correlation. So let's plot the scatter diagram. And this is simply plotting points. On one axis we have distance, and on the other axis we have the population density. And all we do is take the two coordinates, 0.6 and 50, and you can see that's the corresponding coordinate there. Horizontal axis 0.6, vertical axis 50. And we continue to do that. We can pick another coordinate, say this one, 320, and on the diagram, where is that? That is, you can see here, horizontal coordinate of 3, vertical coordinate of 20. And you continue until you have plotted all of your points. Make sure you label your diagram, and you can see that we have used a scale on the axes as well. So this is the scatter diagram. Part B was to consider the type of correlation. Now we can see that we do have a straight line pattern, and it is an arrow going down, so this means that as one variable increases, the other variable is decreasing. And we can see on the diagram, as the distance is getting larger, then the population is going down, is decreasing. So this means there is negative correlation. Part C is to interpret the correlation. So what do we mean by interpret? Well, when we ask you to interpret the correlation, what we mean is to consider the actual variables, and we must refer to the variables, the context of the question. Now, our variables were about distance from the centre and population density. So there's negative correlation. As distance increases, then population density decreases. And that's what we've said here. So this is our interpretation. Distance increases, population density decreases. Okay, let's look at another example. Example 2, the scatter diagram shows the pulse rates in beats per minute and the breathing rates in breaths per minute of 12 people. And here is the scatter diagram. Describe the type of correlation and interpret the type of correlation. Okay, so type of correlation. Let's look for the pattern. Now, we can also see from this scatter diagram that the scales do not have to start at 0. And you can see that here. We haven't actually started at 0, we've started at 40 and 15. This just makes it easier to draw the scatter diagram. If there are no values between 0 and 40, then we don't really need that part of the diagram, and no values between 0 and 15. It's just going to be a blank space, so you don't have to draw it. Another thing to consider is when you're drawing the scatter diagram, choose a suitable scale according to the data values. And you can see here that different scales have been used for each axis. The breaths per minute, this scale, we can see that 1 square is actually 1 breath per minute. But on the vertical axis, 1 square actually counts for 4 beats per minute. And this is perfectly acceptable. Again, it will make it easier to read and draw your diagram. So let's look at the correlation now. And we can see the pattern. We have a straight line pattern. and the arrow is going up. So what this means is that as the horizontal variable increases, then the vertical variable also increases. And this tells us that we have positive correlation. Now to interpret that correlation, and remember, when we are interpreting, then we need to consider the context of the question, and the question is about breaths per minute and pulse beats per minute. So our interpretation is that the positive correlation means as the breath rate increases, then the pulse rate also increases. So there's two examples. Finally, let's just look at another way for defining correlation, or rather deciding on what type of correlation we have. And we can consider the mean values here. And what we do is we consider the mean value of the vertical variable, call it y bar, and the mean value of the horizontal variable, call it x bar. And what we do is draw a horizontal line through the y bar and a vertical line through x bar. And that splits up our diagram into 4 quadrants. Now when we number the quadrants, then this is always number 1, number 2, number 3 and number 4, always in that order. And what we see is that for positive correlation, then actually most of our points are in the first and the third quadrant. And if we consider the same idea for negative and no correlation, we see for negative correlation, most of the points are in the second and the fourth quadrant, and for no correlation, then the points are distributed across all of the quadrants. Yeah, no particular quadrant. So that's a different way of deciding whether you have positive, negative or no correlation using the mean values of your variables. And here is a quick summary. For positive correlation, most of the points are in the first and third quadrants. For negative correlation, most of the points are in the second and fourth quadrants. And for no correlation, the points are fairly evenly spread over the 4 quadrants. And in summary, overall, scatter diagrams show the relationship between 2 different variables. Correlation is about the type of relationship between the variables, and in this course we will consider 3 types of correlation: positive correlation, negative correlation, no correlation. But remember, we're talking about linear correlation because we're considering straight line patterns. And when interpreting correlation, talk about the context of the question and refer to the actual variables. For example, we had a distance, a population density, and we had a pulse rate and a breath rate. So, now try the question.